Walk one yelly coolness. I check this. Man knows man hasn't been spitting that knowledge in your skull. But check this. Man accidentally tripped and headbutted one pagan for talking tough. But unfortunately, my skull got damaged in the process. So man had to run to the hospital. And the doctor did a little kung fu and flagging me back to life. But anyways, look, let's jump straight to this. A little lightweight thing as usual. Man's gonna take difficult and make it into a little simplification. So give me a sec. Let me drink a little something. You don't know the pattern. Okay. Okay, a little something to get me started. So let's take a look at this question. Now listen. What man's going to be going through is the vectors, okay? So basically, in this video, I'm expecting you to have, some small understanding, fundamental knowledge on the vectors. Now, if you don't, I'd highly advise you to go do that because I'm not going to go too deep into too deep into the topic in this video specifically. But what I am going to do is I'm going to explain what I'm doing. I'm going to explain what it means and so on and so forth. So if you have a small understanding of this topic, this is going to be a bit easier. If you have no understanding at all, I would highly advise you to go and go through the topic first and come back. So let's jump straight to this question. It's got a part A, it's got a part B, it's got a part C. What? We're probably going to go through a couple questions in this lesson. So let's get started. Give me a second. Let me get this stuff. Okay, cool. Now listen, yeah. Forget about part A for a second. Let's just not think about part A. Let me just look at this, yeah. So basically what this is telling me this is line 1, okay? A random line called line 1, yeah? Now, what this is the equation for a vector. This is the format, yeah? Now, it's very important you understand what this is. It's very important you understand what this is. And it's also very, very important you understand what this is. So let's go through that step by step. Number 1, yeah? This thing here is a random point on that line. What we call it the position vector, yeah? Let's understand that, yeah? Remember what I said, a random point on that line. So let's just say if this is the line, this thing here is a random point on the line, L1. So remember, this is L1, yeah? Let me just put L1 here. So this is a random point on the line. It could be anywhere. The point could be here, it can be here, it could be here. It doesn't matter. We don't care. We don't know. It doesn't matter. But we do know that the position vector, which is this, is a random point on this line here. And we can put it here, like, for example, here. So 2, 3, minus 1 is a random point on the line. And we're going to put it here. Calm. Next thing, yeah? This here is what we call lambda. Don't worry about it too much now. I'm going to explain what that is, but this is what we call the scale factor, yeah? SF, scale factor, the scale factor, yeah? Calm. Now, the most important thing on this line here, they're all important, but you need to differentiate the differences between these two very, very clearly. This thing here, this minus 143, is what we call the direction vector. Now listen, man's going to explain what that means, yeah? Direction vector. Now listen up. This line L1, okay, it's going, at a random. Where is it going? Now I'm gonna use a different way of explaining this. Let me put it in red, yeah. Let's say if you want to go from London to Birmingham, yeah. Let's say you want to go from London to Birmingham. Okay, cool. Now listen. To get to London to Birmingham, you're going to have to go on one of the motorways for a long time. I don't know which it is. Man hasn't been there, you understand? But I've been there, but I haven't done this journey specifically in a vehicle, like in a car or something like that on my ones, you understand? But listen, to get from London to Birmingham, you're going to have to stay on one of the motorways for a long time. The direction you're going in is what we call the direction vector. Let's just say the motorway is called M7, yeah? You're going to have to stay on the M7 for God knows how many hours, yeah? Now, you're going to be going consistently in one direction. That's what the direction vector is telling us. It's telling us the direction we're going to be going in for a very long time, okay? Now, as I said, this is the direction vector for this line. So therefore, the direction this line is going in is minus 143, okay? So remember, from London to Birmingham, the direction vector might be like 9, 7, 10. Okay, I don't really care what it actually is. I'm just trying to explain to you why the direction vector is so important. It's basically telling us which direction this line 1 is going in. Okay, so for example, line 1 could have been, 10, 9, 70 for the direction vector. So therefore, it might have been going this way. You get me? 10, 9, 70. It will go this way forever. You understand what I'm saying, yeah? I hope you're understanding what I'm saying. by, you know, I hope you understand what the direction vector is, okay? I don't want to spend too much time going into too much detail, but that was just a slight example. Now, let's look at lambda, okay? Why is lambda important? So remember, the direction vector for this line is -1. Let me put it up here, actually. I don't like it. Let me put it up here. -1, 4, 3, okay? Now, if you don't mind, I'm going to rub out the position vector and direction vector thing. Give me a second. I'm going to rub this out because it's taking too much space. Can't lie to you. Give me a second, yeah? Now, let's look at that lambda thing, yeah? You know what I will do, yeah? Let me just rub this out. Now, let's look at that lambda thing, yeah? Now, what is lambda, yeah? Let me explain. Remember, we're going from London to Birmingham, yeah? Now, the direction vector, let's just say, for example, the direction vector is something like, let's just say it's -143, okay? Now, from London to Birmingham, best believe you're going to need to be filling up that petty, you understand? The petrol in the car is not going to last too long, so you're going to have to make stops, okay? Now, let's say the petrol station, one is here, and one is here. Now, what the lambda does, the scale factor thing here, now remember, it doesn't have to be lambda, it could be T, it could be R, it could be F, it could be whatever you want it to be, but more time in questions they put lambda, yeah? So let's say we put lambda here. What lambda does is it finds the, when we need to stop. For example, if I want to stop here, I would put lambda equals 1, okay? If I put lambda equals 1 here, this is the distance I need to travel, like this is what I need to travel from L to get to P1, which is the first petrol station. Let's say if I want to get from L1 to P2, therefore lambda would be 2, for example, okay? From here to here, lambda will be 2, okay? So basically, it's very important that whatever you put in lambda gives you the different distances from the original point. So for example, from here to here, lambda equals 1. From here to here, lambda equals 2. From L to B, lambda equals 3, okay? So it's very important. You can also find the differences in distances using the lambda, okay? I hope you're understanding what I'm saying. Yeah, I hope you do. And if you're not, then listen, listen, at the end of the day, I told you in this video, what I'm trying to do is I'm trying to just go through the questions. I'm not trying to explain too much into detail. I will make a video eventually on that. But yeah, anyways, let me continue with the topic here. So remember what we said, yeah? So remember that, yeah? So direction vector, the scale factor, R equals 2, 3, -1, so on and so forth. Oh, no. Yeah, calm. All right, now let's actually go through this question, yeah? Give me a second. Let me wrap all this out. Let's go through part A now. Give me a second. 1 second, rude boy. 1 second. Let me just rub all this out. I'm just going to sketch it again. Alright, cool. So, remember, yeah, man's going to sketch line 1 real quick. Let's say this is line 1. Boom. There's a random point called 2, 3, -1 here. And then the direction is going in, which is the one we've picked right now. That one there. The direction vector is going at this thing here. -143. -143. And then make sure you put the lambda, okay? Calm, that's the direction vector. Okay, cool. Now look at the question. It says line L2 passes the origin. So it's basically telling me this line L2, okay? This line L2 passes the origin. So it goes through the origin. So a point on that line is the origin. And it is parallel to L1. Now what does that mean? It's parallel to L1, okay? Now let's be very clear here, yeah? If this is line L1, and line L2 is parallel to it, therefore they're going into the same direction like this. This has to be also line L2. Let me do a different color, man. Let's use the red one. This has to be line 2 as well. Now, why do you think that? Let's just say, for example, let's be very clear here, yeah? If we're both on the motorway, we're both going from London to Birmingham, yeah? You're going from London to Birmingham. I'm on the next lane right next to you. I'm also going from London to Birmingham. Therefore, we're parallel to each other. You understand? We're parallel. That's what parallel means if you didn't know, okay? I hope you did know by this stage, because if you didn't, man's going to have to come and give you the one happy sloppy. You understand? So let me continue anyway. Alright, cool. So it's telling me line L2 past the origin and is parallel to L1. If it's parallel to L1, they're going in the same direction. Therefore, the direction vector for L2 has to be exactly the same direction vector as L1 because they're both going in the same direction. So it's going to be -1, 4, 3 for the direction vector. However, let's just say, for example, the car might be different. You understand? So you're not going to put lambda. You're going to put something like T, for example. You could put T. You could put mu. You could put R. Basically, in every single question, do not put the scale factors the same because you don't know the scale factors unless they tell you the scale factors are the same, which tends to never happen. But just make sure you don't put make sure you didn't put lambda here as well. You understand? You have to change that. You can have the same direction vectors, but do not put lambda in this one also. Okay, calm. Now that we've got that calm, now we need to find L2. Now remember, yeah, how you do it is you put R, just like this thing R. You put equals. Now we need a random point on this line. Okay. Now, in the question, as you can see, it says passes the origin, okay? So let's say, for example, this is the origin here, 0, 0, 0. That's what the origin represents, 0, 0, 0. So therefore, remember, this is a random point on the line, so man can put 0, 0, 0. Okay, so this is the position vector, a random point on the line, plus t, and then we put the direction vector, which we know is minus 1, 4, 3. So remember what these represent. I'm going to go over it one more time. This here is the position vector, a random point on the line. This here is the scale factor. This here is the direction vector, the direction in which this line is going in, okay? So just like this, a random point on the line, because it was given to us that it passes the origin, calm. This is the scale factor, t, and this is the direction vector, the direction in which line 2 is going. Calm, little light work thing. Now listen, I hope you understand what I'm doing. Now let's go through part B. Give me a second, let me just wrap all this out. Alright, cool. So look, part B now, yeah? This is a little light work thing, yeah? And these questions tend to come up. So it says, the point A and the point B lie on L1 with parameters lambda equals 0 and lambda equals 3. Basically telling you the scale factor is 0 and the scale factor is 3. Find A and B. Now remember what I said, yeah? Remember what I said, it's really important, yeah? This line L1, remember how it looks, yeah? It looks something like this, yeah? And then we knew that there's a random point, 2, 3, minus 1. No one really cares right now, okay? And then we also know it's going in direction vector minus 1, 4, 3, okay? Now, they're telling me the point A on this line, somewhere on this line, only happens when lambda equals 0. So man can easily find that by slapping it into this equation here, yeah? So remember, yeah, for the point A, let me put it in a blue color, yeah? Give me a second, yeah? For the point A, okay? It's telling me the point A happens when lambda equals 0, okay? Now, this equation of the line here, r equals 2, 3 minus 1. And then for lambda, I'm going to put 0 because that's when A happens. So if I put plus 0, minus 1, 4, 3. Now, listen. If you put 0 here, how you do this, yeah, is you do r is equal to 2, 3 minus 1. Sorry. 2, 3 minus 1. And then what you would do now is you would do 0 times minus 1, which gives me 0. 0 times 4, which gives me 0. 0 times 3, which gives me 0. You understand? I'm just doing it just to show you how you do this. So therefore, the only thing left is this. So therefore, this is A. You understand? Yeah, this is A. Yeah, this is the point A. Okay? So the point A is 2, 3, minus 1. Calm. So now let's find the point B. I'm going to rub this out. Give me a second. Let me rub this all out. So the point A, and listen, it could be anywhere. Oh, obviously in this case, luckily, this is the point A, 2, 3, minus 1. So we got lucky there, you understand? So we got lucky there. Anyways, cool. Now, it says here, lambda equals 3 is for point B. So let's now find B. So remember, what you do is you take this equation of this line, okay? You take the equation of the line 2, 3, minus 1, plus lambda, minus 1, 4, 3, calm. Now, you put lambda equals 3 for the point B, okay? So therefore, the point B is equal to the 2, 3, the minus 1. But lambda is now 3. Okay? For point B. Minus 1, 4, 3. Calm. Now therefore, the point B is that 2, 3, minus 1. Now remember, I told you how you would do this, yeah? 3 times minus 1 is minus 3. So I'm going to put minus 3 up there. 3 times 4 is 12. So I'm going to put 12 in the middle. 3 times 3 is 9. So I'm going to put 9 there. And then what you do now is you individually add up the things in the rows, yeah? So for example, B, oh, I don't even know if I have enough space for this. Do you not mind if I take it up here for a second? Yeah, give me a second. So B is 2 plus minus 3. So 2 minus 3 is going to be minus 1. Okay? The middle row, 3 plus 12. Okay? So 15. Let me put that there. Minus 1 plus 9. So plus 8 is going to be the answer. And that is your coordinate for B. So B, obviously, look, this is A, so B might be here somewhere. Do you get me? So minus 1, 15, 8. Okay, so I hope you're understanding what I'm saying right now. Now, let's go to part C. Wait, 1 second. Do I have part C? Yeah. So let's go to part C now. Okay, so I'm going to rub this all out. So copy it down. I'm going to rub this all out. Give me a second. Okay, now listen. Let's look at part C, yeah? It says, find the size of the acute angle between OA and the line L1 in degrees. Now listen, yeah? OA means from O to A. Now, oh shit. Now, O normally represents the origin, okay? So let's just say, for example, on this green line here, which is the line L1, don't forget that, yeah? O is going to be, let's just say here. Okay, this is OA. So 0, 0, 0, which represents the origin. Okay, now listen up. It's telling me to find the size of the acute angle between OA and L1. Now listen, yeah, there's a very important equation I want you lot to remember. And that is cos theta, which is the angle they want us to find, equals small a, small b, modulus of small a, times modulus of small b. So this is small a dotted with small b, okay? And then the modulus of small a times by the modulus of small b. Now listen, the reason I'm saying small is because in vectors, the small letters, so not capitals, yeah, so small letters represent direction vectors, okay? Now listen, my guy, this is really important for you to understand, you understand? This is the position vector. We never ever use position vectors in this equation. The only thing we use in this equation, yeah, is the direction vector, okay? Now, OA, we can find the direction vector of OA, because deep this, if I calculate OA, that will give me the direction vector of OA. Now, luckily in this case, because it's on the same line, of course it's going to have the same direction vector because it's in the same line. Remember what the direction vector is. The direction vector is what direction it's going in, right? So if it's on that line, it's going in the same direction, okay? Now, let me drink water. Listen, relax, my throat's a bit dry. Give me a second. It's been a long time. It's been a long time, you understand? Oh, fuck. Okay, now listen. In order to find OA, normally what you do, OA is A minus O. That's just how it works. For example, if you were to find CB or DR, yeah, CB would be B minus C, okay? DR would be R minus D, okay? So I'm just trying to explain to you what I got, yeah? Cool. Let me rub all this out, yeah? Now, luckily for us, OA, yeah? A minus O, yeah? That's what it is, yeah? A minus O. Now, A is obviously 2, 3 minus 1. Minus O, which is the 0, 0, 0. So it doesn't make no difference. So remember, what we just found the direction vector from O to A, okay? That's the direction vector. So lambda here, lambda would equal 0, okay? So to get from O to A, lambda would be 0. Obviously, I'm just letting you know, that doesn't really matter. But more time, when you take away 2 points, so when you take away O from A or A from B or whatever it is, you're basically finding the direction vector from those 2 points, the distance from those 2 points, whatever it is, okay? Okay, let me carry on anyway. I don't want to talk too much, man. Give me a second. So OA is 2, 3 minus 1. So basically OA is going to be small b because that gives us the direction vector. That's what the arrow up there indicates. So therefore A is going to be what we just calculated, which was 2, 3 minus 1. Now it says find the size of the angle between OA and the line L1. So we also need the direction vector of L1. Now, do we know the direction vector of L1? Yes, we do, because this is the line L1 and this is the direction vector. So therefore, small b is equal to minus 1, 4, 3. Remember what I said? In this equation, the only thing we're dealing with is position vectors, okay? Sorry, shit. The only thing we're dealing with is direction vectors. Don't forget that. Do not ever use position vectors. That's why it's so important you remember the small letters represent direction vectors, okay? Nothing else, okay? Now, obviously, this one was a bit weird because the direction vector for this is also the same as the position vector, but, you know, you get lucky. Normally, it's not like that. Normally, it's a bit different. Okay, cool. Let me carry on anyway. So now we know what A is. Now we know what B is, okay? Now we're going to apply it to this equation. So, A, small a, is going to be 2, 3 minus 1, okay? Dotted with small b, which is minus 1, 4, 3. All divided by the modulus of A. Now, what does the modulus of A mean? The modulus of A means you square root. Remember, this is A. What you do is you take the 2 here, you square it, you add it to the 3 squared. You add it to 1 squared, or minus 1 squared. Doesn't make a difference, okay? Okay, cool. Then you times square root, same thing here, minus 1 squared, so 1 squared doesn't really matter. Add it to 4 squared. Add it to 3 squared, okay? I know it's running out of space, sorry about that. So therefore, cos theta. Now how you, let me actually not write cos theta. So how you simplify the top one, what you do is you do 2 times minus 1, which is minus 2, okay? Then you do 3 times 4, which is plus 12, okay? So I'm gonna put plus 12 here. Then you do minus 1 times 3, which is minus 3. That's how you simplify the top there. divided by this if you put it in your calculator, and if you times it by this in the calculator, you should get, I'm not sure what you get, but obviously check what it is if you do this, whatever this is, yeah? And then, because I'm not going to have enough space, yeah? I'm not going to have enough space, but that's how you do the top, and then you should get theta is equal to 68.5. This is what you should get, okay? Actually, you know what, yeah? Let's actually just quickly write that out. So remember how you simplified this, yeah? So remember, it was minus 2 plus 12 minus 3. That should give you 7. So it's going to be 7 on the top, okay? Then you put this in your calculator. Square root of 2 squared plus 3 squared plus 1 squared. That should give you square root of 14. So let me put that there. Times this thing, 1 squared plus 4 squared plus 3 squared. That should give you root of 26, okay? Now you put this in your calculator. If you do the inverse of cos, you should get theta is equal to 68.5. Okay, so listen, I hope you're understanding what's going on here. Another thing that's really important, yeah, is that this theta, yeah, if it was negative, that would not be your final answer. If theta is negative, you would have to do 180 minus theta, and that would be your answer. Don't ever forget that. If theta was negative, you would have to do 180 minus theta, okay? I hope this question betters your understanding. Now listen, I was going to do another question in this video, but the next questions I'm going to go through is going to be way more difficult than this question here. Now obviously, I don't want to make this video too long. This was more just to help you understand the fundamentals of the vectors, okay? So listen, I hope this video helped. There's going to be more parts coming soon. Love.